So in previous videos, we've looked at absolute value equations, and we've looked at inequalities, but now we're going to look at absolute value inequalities. We're going to combine several ideas here. And so, in order to understand the absolute value inequalities like we're showing here and here, let's revisit our idea of absolute value equation. And we said an absolute value equation is a distance from zero. So if this distance from zero is 5, well, we said, okay, well, that could be over here at positive 5, or that could be over here at negative 5. So for this, it could be either one of those. 2x minus 1 could equal 5, or 2x minus 1 could equal negative 5. Now, let's kind of tweak this understanding of the absolute value equations to help us understand the absolute value inequalities. Now we're saying we want a distance less than 5. That means whatever number this is, it needs to be closer to 0 than 5. So that means it's not just 5, it's the numbers less than 5. Okay? And in fact, it's not 5 because we don't have the or equal to. We need a distance less than 5, not less than or equal to 5. And that would mean also, if I want the distance to be less than 5, well, we also have numbers over here that are less than 5 away from 0. So I could also have all of these numbers. All of these numbers have a distance less than 5 away from 0 as well. So if I kind of keep that in mind, we're actually going to solve this as two separate inequalities. We're going to say 2x minus 1 is less than 5, which I've represented in blue on the number line. But we're also going to say 2x minus 1 has to be greater than negative 5. Hopefully you see why I'm using the greater than symbol. I'm using the greater than symbol because all of these numbers to the right of negative 5 on the number line are greater than negative 5. So this blue inequality represents the values here. This red inequality represents the values here. So now let's solve for just our individual values of x. Here I'm going to add 1 to each side. And I'm going to divide by 2 on each side and say, okay, well, any x value less than 3 would result in some number here. Okay? And then I'm going to add 1 to each side. And then I'm going to divide by 2 on each side. And so any value of x greater than negative 2 would result in a number here. So this is our solution set. X is less than negative 3 and x is greater than negative 2. So we could write that a couple of different ways. I could write that as an inequality. This is saying the part in red, and this is saying the part in blue. Or I could write it with the good old interval notation and say that, okay, here's our values not including negative 2 or 3. Now, let's look at this again. I'm going to kind of erase a bunch of stuff. But I'm going to leave this, and let's look at this last example. I don't have a ton of room down here, but I really want us to understand this. Let me erase my number line. So here, now we're looking for a distance that's greater than 5. So we're thinking, okay, what numbers, where do they live on the number line where their distance from 0 is greater than 5? And so if I look, here's 5, okay? But the numbers that are further than 5 units from 0 would be all these guys over here. So we're now actually going to write inequalities to represent those values. And that means there's going to be some more numbers that have a distance greater than 5. And so there's numbers the number that's a distance of 5 away from 0. But we're looking to represent all of these values going on forever that way. Okay? So now it just means that our inequalities that we set up are going to be a little bit differently. I'll represent these blue values first. So there we're looking for values of 2x minus 1 that are greater than 5. But then in red, we're looking for values of 2x minus 1 that are less than negative 5. So it's not that I just changed this to a negative, but I also have a symbol facing the other direction. Because all of these numbers are less than negative 5. Negative 8 is less than negative 5. Negative 12 is less than negative 5. That's how we represent these. And so I'm going to solve these two inequalities. So we have x, let's see, I'm going to add 1 to each side. I think that's going to be x is greater than 3. And then over here, I'm going to add 1 to each side. I think it's going to be x is less than negative 2. And so how we'd represent these numbers is, since there's no overlap, since there's no intersection, I've got to write the interval notation a little bit differently. We're going to say for the red, it goes all the way from negative infinity up to -2. And for those blue values, it looks like any value greater than 3. So we're going to go from 3 up to infinity. And so that would be our interval notation. Honestly, for something like this, I wouldn't even mess with an inequality notation. It would just get kind of gross. Let's do one more example. So here we have an absolute value inequality. I'm going to start by isolating our absolute value symbol. So I'm going to start by subtracting 8 from each side. And actually, I'm going to try to keep everything color-coded like we have been. So I'm going to subtract it in green. And now we have that 4v minus 7. You got to be careful and make sure that doesn't look like a 14 and a 71. So we'll have to remember that later. Is greater than or equal to 9. And so what that means on a number line is here's 9 and here's -9. So since we're looking for a distance that's greater than or equal to 9, that means we're going to have values that include 9 and go to the right. And this time we're including it because we could say, okay, it could be exactly 9 because of this symbol. But also, all these numbers over here on the left would have a distance of greater than 9 away from 0. So I was going to figure out how to represent these two values using inequalities. So it looks like our blue inequality would be, okay, well, that's just when this expression is greater than or equal to 9, but then the red inequality is when this expression is less than or equal to -9. That's how I'd represent these numbers over here. So let's solve each of these. I'll solve the red one first. So I'm going to add 7 to each side. And then I'm going to divide by 4 on each side. And then we'll solve the blue inequality. So I'm going to add 7 to each side. And then I'm going to divide by 4 on each side. And so we have our solution set. Since there's no overlap in these, there is no intersection, I'm going to write it using inequality notation. So to write this, I know that that's numbers from -infinity all the way up to -1/2. Now, because we are including the -1/2 itself, we're going to put our bracket. And then we're going to go from 4 up to infinity. And once again, since we're including the 4 itself, we're going to use a bracket there. So this right here would be our solution set to this absolute value inequality.